Okay. Good afternoon, ladies and gentlemen. Thank you for hosting me and my company. The paleotectonic evolution of Anatolia Peninsula commenced with the progressive amalgamation of Gondwana and Laurasia continents to form the supercontinent of Pangaea during the Permian and Triassic times. New tectonic features of Anatolia were shaped in Neogen as a result of compressional tectonic regime between Arabian platform and Eurasian plate. Metallogeny in Turkey is mainly a result of development of Tethyan belt within the Alpine Himalayan orogenic system that formed from the Jurassic, Cretaceous to present time. Crystalline basement is characterized by metamorphic massif. Some of them is Strangia and Kazdan Massif is northwestern Turkey, Menderes Massif in western Turkey, Kırşehir Massif in central Turkey, Bitlis and Pötürge Massif in southeastern Turkey. The wide variety of geological and tectonic setting in Turkey makes the country favorable for wide spectrum of mineral deposits associated with subduction, collision, post-collision, and rifting processes. Anatolia has long been focus of the geopetrological studies and has a history of exploration and exploitation of metals and other mineral commodities dating back to BC. But only during the past 3 decades have the metal endowment of country have been appreciated. Recently, country has become a world-class exploration frontier especially for gold. The country has the largest prospective land area in Europe, approximately 780,000 square kilometers. Turkey is an underexplored country with a large and diverse mineral resources base, as well as being an underexplored portion of Tethyan metallogenic belt. Although there are numerous mineral deposits in Turkey, most of them are modest size by world standards, with the exception of industrial minerals. The mineral industry is an important component of Turkish economy. Copper, lead, zinc, iron, gold, chromite, mercury, saprolite, borat, and troina are the traditional minerals of Turkey. Of 90 minerals traded in the world market, only 13 of which are not present in the country. Turkey has the source superiority for 50 minerals and insufficient resources for 27 minerals. Currently, 53 kinds of minerals are produced. Country is a major producer of industrial minerals, being among the top producers of boron. Turkey is the world's second largest producer of troina. There are 2 troina deposits totaling 836 million tons. Country is among the top producers of chromite and a major world producer of barite, lignite, magnesite, and marble. In terms of high added value products, Turkey has a competitive power in iron and steel, cement, glass, ceramic, chromite, marble, and magnesite products. Country has also considerable geothermal energy resources. The country ranks first in the European Union and 7th in the world in terms of geothermal resources. As a result of geothermal energy exploration, more than 600 whole water resources with a temperature of above 100 centigrade degrees have been discovered. About 184 geothermal areas with the temperatures over about 35-40 centigrade degrees have been discovered by the drillings carried out by MTA. The first geothermal research began in 1962 by the MTA, and it continued to be enlarged for more than 50 years. From 1990s until early 2000s, geothermal research program came to halt due to some economic policy. After 2004, a new period of exploration program began, and drill holes have significantly increased tenfold from 2,000 meters by about 30,000 meters. Most of mines produce relatively small amounts of metal, such as lead, zinc, and antimony, with the exception of copper. Numerous copper occurrences are concentrated across the country. Main gold Copper deposits are mainly of porphyry and epithermal types associated with volcanoplutonic arcs. Anatolize and orogenic belt are the most prolific porphyry belt in Turkey, with two of the largest gold deposits. Copper, lead, zinc deposits are the mainly of VMS type, especially Kruko and Cyprus and Mississippi Valley types. Nearly all the known chromium deposits are podiform type related to alpine ophiolitic rocks. Epithermal gold, silver deposits are the mainly concentrated in the western part of Turkey. In northeastern part, epithermal gold, silver mineralization are associated with submarine subrareal volcanic rocks, whereas subrareal volcanic rocks in the western part. And orogenic gold mineralization are specially associated with pre-Mesozoic massifs extending along the middle part of Anatolia Peninsula. Despite a long history of placer mining, a few placer deposits of Turkey have current economic interest. The country holds promises for further discoveries of gold. Ophiolite-hosted lateritic nickel, cobalt occurrences make the Turkey attractive for the further lateritic nickel exploration and mining. Many foreign companies have been conducting exploration activities to explore untapped mineral wealth, especially base and precious metal. Change in Turkish mining law and increasing metal prices have boosted mineral exploration activities, resulting many discoveries. In 1990s, economic policy and exploration strategies led to stagnation of coal exploration activities. In the years following, increasing exploration in the country led to a considerable number of lignite discoveries, amounting to 5 billion tons. There has been an increase by 60% in coal reserves from estimated 8.3 billion tons to 13.3 billion tons. Turkey ranks 6th in the production of lignite in the world, also ranks 7th in terms of lignite reserves. According to the Turkish mining law, minerals are under the ownership and domination of states and are not considered to be property of landowner where they are found. Government has a right to give permission of exploration and exploitation to private individuals or companies or public organizations. Mining rights in Turkey may be granted either to Turkish citizens or the state enterprises authorized in the mining activities or corporate bodies established on the basis of Turkish Republic laws. In this context, companies with the foreign capital established on the basis of Turkish Republic laws can also obtain mining rights in Turkey. MTA, Mineral Research and Exploration General Directorate, is a leading state-run company conducting mineral explorations throughout Turkey, and a national center for creation knowledge infrastructure, information in earth science. MTA was established with the aim of conducting scientific and technological research on mineral exploration and geology. MTA, which carries out geological research at sea and land, provides effective use of new ore deposits and energy raw materials by performing scientific research related to exploration. In this context, MTA plans to carry out more than 300,000 meters drilling per year to discover new mineral and energy resources. MTA offers a wide-ranging program for both field and classroom-based development training courses for agencies and associations in order to contribute mining sector. MTA facilitates collaboration with universities and institutions across the country through the joint ventures. The company has great contribution in discovering or developing the underground resources to date. It carries out important works for search of many hypothetical and speculative mineral deposits and producing relevant basic geological data. MTA General Directorate has improved its functional structure since the date of its establishment and became an institution providing service in every field related to geology. Our institution today carries out following: preparation of basic geological maps, remote sensing and GIS applications, marine research, karst and cave surveys, determining areas of natural disasters like earthquake, landslide, flood area, and collapse area, Our organization operates in every field of geology, mainly with respect to mineral exploration, but it transfers mine operation to other organizations and the private sectors. Company has a great contribution to discovery or the development underground resources of country. A variety of exposed rock types in Turkey and developed geological and geotechnical environment conditions indicate the possibility of an important potential by new underground resources yet to be discovered in buried environments. In addition, to know the facts with respect to new exploration activities by MTA and private sector. There are various projects applied and planned by MTA on this matter. MTA conducts extensive and comprehensive work with respect to discovery of these resources. In addition, technical support is provided to private sector. Although ore deposits and prospects in Anatolia have been studied extensively, geodynamic processes that control their genesis, location, and timing remain poorly understood. Considering just one deposit and or district cannot explain the key geological features that can be applied globally. In order to understand the process that controls the formation and distribution of these deposits, global comparison is a useful tool to obtain the information on key features that are common to all districts. Assuming that orogenic belts recognized throughout the world have distinctive geological features such as geodynamic, mineralogy, stratigraphy, and ore facies. It's not easy to make global comparison of these districts. Ore deposits to be compared must have well-preserved primary features. Some terrains containing ore deposits, such as VMS, commonly have been subjected to green schist facies or higher grade metamorphism. Intense deformation and associated metamorphism could destroy evidence of primary ore facies characteristics. Generally, primary features of most of the known deposits are not well preserved due to extensive metamorphism. In contrast, primary features of some deposits, such as Eastern Pontite Belt VMS deposits, are largely preserved due to region's non-metamorph nature. The area should be targeted by researchers. Metamorphic rocks that are widely exposed in our country are speculative potential field with respect to minerals like natural stone, marble, feldspar, mica, garnet, graphite, diaspo, and mineralization of orogenic gold, antimony, and mercury. As a result of complex geological structure in our country, it's considered that there may be many hypothetical and speculative underground resources that are yet to be discovered. Due to deep drilling in most of exploration programs in Turkey, porphyry potential at depth remains untested. Some terrains, such as most northeastern part of Anatolia, are covered by tertiary volcanic cover. These volcanic rocks provide areas with exploration potential, especially for epithermal systems. Lateritic nickel deposits were not regarded as economic using conventional pyrometallurgical processing techniques. These deposits should be re-explored in detail. The further deep exploration drill holes must be planned to test some evaporitic basin for discovery of deeper lying sodium sulfate, trona, and borate deposits of world-class grade and tonnage. For all these reasons mentioned above, new exploration projects, including all facilities such as scientific exchange between organizations, collaboration activities, training courses in relevant topics, and drilling programs should be conducted. These projects should be aimed at introducing new technology, methods, and experience to the related partners. Main goal of this project is to make step forward in understanding of where, when, how the mineral deposits form. In order to make this step forward, to compare geology of major metallogenic belt so that key common features can be distinguished. A further reason for choosing this approach is that mining industry and companies now operate with a global perspective and interested in global scientific appraisal of mineral resources. Thank you for your attention. Thank you very much. Any questions?
Благодарю вас за презентацию, за доклад. Следующий докладчик, господин Бенуа Джордан.